Hi, Assalamualaikum and very good afternoon. Today I would like to present my paper with the title of The Design and Analysis of High Q-Factor Frame Buck Acoustic Wave Resonator for Filter in Super High Frequency. The motivation. Research on filter based on film buck acoustic wave resonator (FBAR) or FBAR filter has been widely employed for communication in the RF frequency band 1 GHz to 5 GHz due to its small size, ability to fully integrate on circuits, and good performance. However, the research on FBAR filter is still limited to RF frequency range and thus has motivated further research to be performed in the frequency range higher than 5 GHz. An FBAR filter comprises by several FBARs, hence the overall performance of FBAR filter is dependent on the characteristic of the individual FBAR. Quality factor of F-bar is an important parameter in filter applications as it determines the insertion loss of the filter. Therefore, this work proposed the design and analysis of film buck acoustic wave resonator operating in frequency 7 GHz to 10 GHz with high quality factor. The design of F-bar. As you can see from figure A shows the configuration of an F-bar. Okay, an F-bar consists of a piezoelectric thin film, okay, sandwiched between top electrode and bottom electrode. Okay, the piezoelectric materials can be aluminum nitride, zinc oxide, lithium niobate, and other available material that can be used to design the F-bar. Okay, for bottom and top electrodes, normally the commonly used material are aluminium, molybdenum, titanium, and even platinum. Okay, alright. So this is the substrate. You can either use the silicon or gallium arsenide, okay, whichever suitable with the design. Okay, figure B shows the cross section of the F-bar. Figure C shows the geometrical design parameters that used in this research. Okay, only 3 layers that will be considered in the design, which are the bottom electrode, piezoelectric materials, and the top electrode. And this geometrical design parameter shows the width, length, and thickness each of the layers. Okay, so this is the design parameters used in this research. Okay, for this research, we use the molybdenum as the top and bottom electrode, and we use aluminum nitride as the piezoelectric thin film. Why we choose these two materials? It's from the previous works. It shows that aluminum nitride and molybdenum can give the best Q factor of an F bar. Okay, so basically in this project we are designing the F bar in 7, 8, 9, and 10 gigahertz. Okay, with 4 sets of different areas for each of the F bar. Okay, all right. So how we calculate the thickness, as I mentioned in the previous slides. Okay, the resonance frequency of the F bar is defined by the relation given is Fs equal to VL over 2T. This is the acoustic velocity of the aluminum nitride. And this is the thickness and the frequency. So we can get these values from this relationship. So how we define this, the top and bottom thickness. Okay, from our previous work as well, it has been proved that the ratio of 0.01 for the between the piezoelectric film and the electrode is the best optimized ratio. So that's why we use the 0.0474 for the 7 gigahertz. So the same method applied for all the frequencies here. So this is the result and discussion. The first part we will look at on the first characteristic, which is the electrical input impedance of an F bar. Okay, this figure shows the electrical input impedance at 7 gigahertz, 8 gigahertz, 9 gigahertz, and 10 gigahertz. Okay, as can be seen from this figure, it is observed that when the resonance area increases, the impedance decreases for each of the resonance frequency. So for each figures, you can see the same trend. We can get the same trend for each frequencies. Okay, from the results too, it is also observed that as the frequency increases, the impedance decreases too. This is due to thinner ALN and molybdenum used in the higher resonance frequency. Okay, if you refer to the design parameter table, okay, we can see that the higher the frequency, the thinner the thickness of the ALN and the molybdenum. Okay, what important here? Okay, therefore, by designing an appropriate resonance area, impedance matching of 50 ohm of the F bar can be achieved. Okay. Okay, now we look at on the influence of area size on the electromechanical coupling coefficient K2EFF of the F bar. Okay, as we can see from this figure, okay, the values of the K2EFF doesn't change with the changes of the area size. This is because of the same material used to design the F bar. Okay, but what we can see here is as the frequency goes higher, okay, the values of the K2EFF is decreases. Okay, and this is true if you relate the relationship in the equation 5 in the paper, mentioned in the paper. Okay, finally, we look at on the influence of area size on the quality factor of an F bar. Okay, so we do have the 7 gigahertz, 8 gigahertz, and 9 gigahertz F bar with different areas. Okay, as we can see from this figure, as the area size changes, okay, there's no change in the Q factor for each of the frequency here. But what we can see here as well, as the frequency higher, the Q factor decreases. Okay, so this is true as well if you refer to the equation 6 given in the paper. Okay, so the highest Q factor obtained at 7 gigahertz is 1767 and 1237 at 10 gigahertz. So now we are on the conclusions. So this work has successfully designed and analyzed F-bar working at 7 GHz to 10 GHz by using 1D modeling. The results obtained shows that it is possible to design F-bar with high Q factor at these frequency ranges. The result also shows that area size has significant effect on the electrical input impedance. As the area size increases, the electrical input impedance decreases. On the other hand, the area size has no significant effect on the electromechanical coupling coefficient and the quality factor of the F-bar. Okay, for the future works on designing the F-bar by using the 3D finite element method, FEM is devoted to further optimize and analyze the performance of the F-bar. The optimized 3D FEM results can be implemented to design an F-bar filter at frequencies of 7 GHz to 10 GHz. So that's all from my part. Okay. So if you have any further inquiries, you can contact me at this email. Thank you very much.